There are three general types of hazards that can occur in food and lead to foodborne illness. The first are physical hazards. These are items like glass, metal, bones, wood, etc., that inadvertently end up in food and can cause damage to the mouth of digestive tract if ingested. The second type of hazard is chemical hazards. Chemical hazards include allergens, chemicals from processing or sanitizing, mycotoxins produced by mold growth, among others. The big nine allergens required for control in the U.S. are dairy, eggs, peanuts, tree nuts, fish, crustaceans, wheat, soy, and sesame. The last group of hazards are biological hazards. This includes microorganisms transmitted by food, which includes types of bacteria, viruses, and parasites that can cause illness in humans if ingested. So, how do we as food processors affect the safety and shelf life of a product? When we are preserving a food, there is an interplay of factors. The first, which we have little influence over, is the intrinsic quality of the food. Here, we have a tomato. The tomato has natural characteristics such as its energy source, available water, acidity, and possibly natural inhibitors to microbial growth. Also, there can be vitamins, minerals, pigments, lipids, and other components of the food that can degrade over time. These characteristics are the intrinsic factors of the fruit that may affect its shelf life. And aside from the selection of the food, we have little influence over these intrinsic factors of our food. Currently, the U.S. has one of the safest food supplies in the world, but this was not always the case. Food safety regulations have evolved over time, alongside outbreaks across various food products in the last 100+ years. The two federal regulatory agencies hold the majority responsibility in regards to food safety. The United States Department of Agriculture Food Safety Inspection Service and the U.S. Food and Drug Administration have authority to enforce food safety regulations within the U.S. and on imported food. The USDA Food Safety Inspection Service enforces food safety regulations on meat, poultry, and amenable species. The FDA regulates basically all other types of foods, including produce, seafood, dairy, juice, and processed foods. The Food Safety Modernization Act, or FSMA, is an FDA regulation that applies to the majority of food produced and imported into the United States. Signed into law in 2011, FSMA was the largest overhaul to food safety regulations in the U.S. in over 70 years and is highly focused on preventing foodborne illness. Under FSMA, the FDA established 7 major rules to implement the regulations. The 7 foundation rules are shown here. The current good manufacturing practice, hazard analysis, and risk-based preventive controls for human food are commonly called the Preventive Controls Rule for Human Food, or PCHF, or PC Rule. This rule has the requirements for processed food production. The standards for the growing, harvesting, packing, and holding of produce for human consumption is commonly referred to as the Produce Safety Rule. This rule is the first federally mandated food safety regulation that applies to farm produce production. These other rules may certainly apply based on a food processor's operation, but we are going to focus on the PCHF and PSR because those are the rules that will most likely apply. We are going to go in depth on the PCHF rule because most processed food producers will fall under this rule, not the Produce Safety Rule. The Produce Safety Rule will apply to all farms that grow, harvest, pack, or hold fresh produce. There are exemptions to this rule based on the types of commodities grown, whether the produce undergoes a processing kill step, and the farm size. The Preventive Controls Rule for Human Food rule applies to facilities that manufacture, process, pack, or hold human food, including both domestically produced and imported foods. There are some modified requirements to the rule based on the size of the business. The reason why the Produce Safety Rule may apply to food processors is because there are certain types of low-risk processing activities allowed on a farm and can allow for a farm mix type facility exemption from the Preventive Controls Rule. This is a very limited list, and we will discuss some of them. In this slide, I want to introduce this general concept of the hierarchy of food safety risks associated with different food types. The lowest risk foods are those with the lower water activity and/or low pH. Their high acid levels or low water content of these foods make it unlikely for foodborne pathogens to grow in these products. That doesn't mean they're free of risk, but they typically can be produced with the lowest level of regulatory oversight. However, the more of these low-risk foods we produce, the more regulations apply. As the number of people eating food expands, so do the regulations. Medium-risk foods listed here have to be produced in a controlled manner to ensure their safety. Highest-risk foods can pose a very serious health risk if they are not produced under very strict controls. Additionally, many of these food types can also cause botulism if improperly processed. Due to their health risks, these high-risk foods have the most regulations associated with them. Generally, as the risk level and associated regulations increase for the particular product, the manufacturing cost also arises. I want to give a few examples to highlight the difference between low and higher risk food types. Many fruit-based jellies and jams are considered low risk due to the high acid levels in fruits and the fact that adding sugar reduces the water activity of the final product. Water activity is a measure of available or free water in a food. This is water that will be available for microorganisms to grow. Physically removing water by drying, for example, is one way to reduce water activity. Also, the addition of sugar or salt binds water in a food, making it unavailable for microbial growth. In this example, we start with an apple that is high in acid, pH well below 4.6, and we add sugar. This combination of low pH and low water activity will inhibit the growth of foodborne microbial pathogens. Gelled preserves rely on the natural acidity present in most fruits for safe food preservation. Jams or jellies from these fruits can be safely canned in a boiling water bath process. Pumpkin, however, has a pH that is higher than 4.6 and is considered a low-acid vegetable. Because added acid, like lemon juice or vinegar, and the lowering of the water activity by sugar are critical for ensuring the safety of these products, they are considered higher risk. Some other fruits have a high pH, including bananas, papayas, melons, and white peaches. In order to produce a safe product and understand which type of food processing regulation applies to your particular product, there are several parameters you need to know. These include pH, water activity, specific details of the formulation, the type of processing being used, the type of package being used, among many others.